How's everybody doing? Awesome. Great to be here. If you want to follow along with the slides, there's some stuff that you can copy and paste and try stuff along with me. This super long URL, you can type that in. Is it? Good to know. Yeah, it's GitHub pages. So. I was going to bit.ly, but I had a bad network last night. So. I think you can handle it. So we ready? We're cool? So I'm Jesse. I've been a PhoneGap developer since the earliest of days, 2008, which is like a lifetime ago now. I was one of the original Adobe team that was acquired by Adobe, and I've been at Adobe for 5 years now, almost 5 years, come November. I've been all over the PhoneGap ecosystem with platforms, mostly iOS, and then I transitioned to do a lot of the Windows work. So I worked with a Russian developer who was sponsored by Microsoft to do the first Windows Phone 7 implementation of PhoneGap. And then, of course, on to Windows Phone 8, then Windows Universal, so Windows 8, all with more and more support from Microsoft over the years. And I'm sure you've seen they've really stepped up how much they actually contribute. It's pretty amazing what they do now. So who's used plugins? I think the answer is everyone, because you can't really do anything without a plugin unless you're just wrapping some simple website, which people actually do too. But ever since 3.0, which was like 3 years ago now, I think, plugins are the way to go. Before that, every plugin was packaged into the app. We always wanted to do a plugin model, but it took us a while to get there. So things were architected like they were plugins, it's just they were always installed. So when 3.0 came out, that's when we introduced the whole CLI and that method of installing plugins. So I'm going to do, most of the stuff that I show is going to be on Mac and iOS. I'll do a little bit on Windows. I'm not actually set up to run Java on this machine, so I don't have all the Android goodies. So unfortunately, you won't get as much info on the Android side today, but hopefully it's stuff that you can all go and apply to Android as well. So how many people here have apps in an app store? How many people are writing plugins or have written a plugin? Cool. That's good to see. How many people have contributed to an Apache Cordova core plugin over the years? Cool. Right on. Yeah, so everyone's used them, of course. But how they work, it's a pretty difficult topic, especially when you put in the fact that you need to learn all about the iOS SDK. Then you got to turn around, you know, Objective-C, Xcode. You got to learn that environment because you're actually developing native parts. Then you turn around if you want to do Android, you got to learn Java. You got to learn the Android SDK. And then if you want to do Windows, then you got another thing to learn. So mostly they work the same across the different architectures. The way that people get plugins now, we used to have a few ways, a few registries. Now we've standardized on using NPM. So I'm sure you're all familiar with this if you want to add the device plugin. You can also install via GitHub URL. Not everyone knows that. It's good too because you can actually install a particular branch or a particular commit. Okay. Check. Okay, that makes it a little more difficult to type, but we'll see how it goes. So you can also install via a local plugin, just from the hard drive. And this is actually the way that you're going to work if you're going to be developing a plugin. And if you're in Mac world, then you can use the nice --" link, which actually means that you're referencing your plugin files without copying them into your project. So that means if you change them inside Xcode, that change is actually in your plugin repo. Otherwise, you're going to have to actually copy your files back out. You still have to worry about that with JavaScript, and I'll show you some of the gotchas around that. So plugin discovery, like I said, we've standardized around using NPM. So if you go to plugins, you're going to see it's actually just an NPM search. And you can see there's 1,276 plugins out in the wild from all kinds of people, all walks of life contributing. And really what we're doing behind the scenes is just an NPM search. We use the ecosystem Cordova within NPM to identify all the things that are Cordova related and not just NPM or JavaScript in general. So there's the list of the core plugins. And I sort of view this not just as a collection of things that you can use to build your applications, but this is actually probably your greatest resource in terms of getting started writing plugins, because if you pick through all of those individual plugins, you'll find that they pretty much cover the entire landscape of things that you can do in a plugin. Whether it's something like the status bar, which actually does some native UI stuff, you know, file transfer, how to deal with all the file system stuff. Camera is a very important one on Android because it uses another activity, which is something that you'll need to know how to do. So really, when I get started writing a plugin, I'll usually grab the device plugin because it's really simple, and I'll use that as a starting point. There's a few other ways that you can do it that I'll show you. So there's the number is still correct. No one's pushed a plugin this morning. Those are the community plugins. There's other people have stepped up and done their own lists, their own registries. So there's this plug reg, which I'm not sure how accurate their numbers are or how often it's updated. And there's also, Telerik has done some work to go through and measure quality on plugins, and if they see that it's maintained well and that there's not that many issues around it, they will actually recommend that plugin, so they have their own listing. So when you get started writing a plugin, plugin XML is your place to start. So plugin XML defines things like the ID for when you publish to NPM. It's also got a version number and typical metadata, author, repo, and it's very similar to package.json, and it will actually get turned into package.json, and I can show you how to do that. So you list your platforms and native headers, source files, any resources that you want to include in your plugin, and your JavaScript interface. You can also do configuration items in there, changes to permissions that you require. JS modules is the main entry point to your application, and this is usually the cross-device portion that you're exposing. And then you can also add hooks, which is very powerful, but I don't think it's fully utilized right now. But hopefully in the future we'll see more hook-related plugin stuff. So I'm going to give you a quick walkthrough of the device plugin, just because it's a simple starting point. So we can look at a plugin.xml here. So we've got some basic version information and an idea that we're exposing. Not all of this information is surfaced through our registry because really what's in package.json is what defines what displays on npm.js. So if we look to, we'll scroll down, actually we'll go to the JavaScript module first. So this is really defining our main entry point, and this is the code that your users or developers using your plugin will interact with. So this is really defining the interface that they'll use. There's a few different ways that you can do this. What clobbers means is that if window device already exists, this will overwrite it. And you can also put these JS modules inside individual platforms. So if I wanted to do a particular device.js on window device for Firefox OS, I could put another one in here and clobber that one. So the top level is always added first, and then the individual platform, it can either merge or it can clobber. So a merge essentially means that if a property exists in your Firefox OS version, it will copy that property over, and it will also overwrite individual methods that you do supply, but you don't have to supply the whole interface. So you can reuse some of the JS module that's global and just add a few methods for a particular device. So scrolling down to look at iOS, there's some other things that we add in here. This is how we decide what plugins the bridge will let JavaScript call. So this is really saying that when I receive a call to Cordova exec with the key device, I'm going to map it to this class. So this is an Objective-C class, and I'll show you that in a second. It's prefixed with CDV here because Objective-C doesn't support namespaces or class paths. So this is a way of making sure that we're not, getting in trouble with somebody else's device .h or .m. And you can see there's actually the files that we're going to add to the Xcode project here, the header and the implementation file are CDV device. So there's nothing else that we're adding here for iOS, no additional JavaScript files, but you could add JavaScript files as well. And if you look at the Windows implementation, you can see that we are adding another module here. Windows works a little bit differently in that there isn't a native layer, but I'll show you that a little bit more as we get going. So if I jump over to the implementation files for iOS, they were listed as being here. So you can see that we're including our header for CDV device. Any plugin that you implement is going to include the CDV.h, which is a core plugin implementation. And if we jump back to the header, you can see that we're actually extending CDV plugin. So CDV plugin does a lot of mapping of properties for us. So when we receive a call from JavaScript, it actually helps us to interpret that data. So jumping back, you can see in the actual this is a command that's actually callable from JavaScript. So it takes a CDV invoked URL command, and that command actually can have things like arguments passed to it. In the case of the device plugin, it's very, very simple, and it's really only going to have we're not using, okay, the command that we receive will have a callback ID. Callback ID is important because you want to make sure that you map your calls back into JavaScript, back to the original code that called. So what happens when a Cordova exec call is made is there's a success and a fail handler that are passed through, and those are stored on the JavaScript side, and they're stored by callback ID. So when we receive a result, we know which callback to actually call. So this is actually doing some work. Self-device properties actually does the native work of actually getting all these properties, turning them into a nice object that can be passed back. And plugin result is created here. So this is an important method that you'll use to generate a plugin result. So you give it a status, and then it'll take this device properties dictionary, and it'll turn it into a JSON object that we can pass back into JavaScript. Also, I just want to mention, if you have any questions along the way, I mean, feel free to jump in. I don't want to talk the entire 90 minutes. I'd like it to be interactive if possible, and if you need me to explain anything in more detail, just feel free to ask. Oh, awesome. Yeah. Now I'm a real star. Need my piano. So that was the iOS walkthrough. I can actually do a quick, where were we? Yep. Yeah, sure.
Just a few organizational things. Bathrooms are over there if you need them. We're going to have coffee and lunch where you enter it. This session is being recorded, which doesn't have a lot to do, but just so you know. Wi-Fi is phone at PhoneGap. And we will have lunch there as well. Lunch will be curry, so I hope you like that. If you don't like it, lunch will still be curry. And that's basically it, I think, unless any of you have some practical organizational questions.
I just lost internet.
Excuse me?
I just lost internet.
Oh, that's not good. But there's supposed to be a cable for you.
Yeah?
I asked for it.
Oh, it's GitHub.
GitHub is down.
Oh.
That's not my problem. Have fun.
Okay. Let's move on. So, who's used Plugman? Has anyone heard of this thing called Plugman? Cool, a few of you. So Plugman is short for Plugin Manager. It's actually what does the work of installing a plugin for a particular platform. It's sort of hidden behind the scenes, but it's used by Cordova Lib to do the work. So you can actually install Plugman as an NPM package, and then you can use it directly because it has its own command line interface. So if you do this, you can install this plugin that you've listed here, and this actually should probably be a modern NPM way of using IDs and not the old-fashioned way. You give it a particular platform that you want to install for and a reference to the project. So this is actually what would normally be in your project root / platforms, in this case, / Windows Phone 8. So Plugman also has a convenient way of creating a plugin, which is super powerful and not very well known. So if you want to follow along here, we can actually create a plugin. I'm going to change my ID. It's going to be Jesse's plugin ID. And I'm going to create it. Name, plugin name. I'm going to give it the same name. Oops. I'm glad I'm not holding the mic right now. Oops, sorry. So a name, an ID, and a version. And no, it's doing the local folder. Yeah, is there one on the, oops. Yeah, there is, I guess it is optional, because it did create it right there, Jesse's plugin ID. So you can see it's created a plugin XML for me, a source folder, and a WW folder. So this is just a good starting point, excuse me, for you to get started. And we can actually open that in VS Code and have a look at what it's done. So it's basically just created this plugin, XML. It's added a JS module for us, and it hasn't added anything to source. It's basically a very simple, dumb plugin. Plugins, of course, can have dependencies, so if we wanted to, we could make this plugin have some dependencies. So now we're saying, you know, I use the device plugin all the time, I use console all the time, so I want those plugins in my plugin. And I've essentially just created a plugin that actually has some use even without implementing anything. So it's just a collection plugin. So plugin functionality, most of this I sort of went over. So here's an iOS implementation. All the, let me pump that up. Here's what we need to actually call status bar style default. In iOS, in the config XML, we're defining the class that we want to call as CDV status bar. And we're actually going to call a method on it called style default. In this case, we're not accepting any arguments. Of course, the plugin callback ID will be there. And then we can actually do some work in our implementation here. Here's an example of just sending some data back to the JavaScript side. So in this case, this is a very asynchronous call. So when this plugin started, we were passed a callback ID, and that callback ID is for something that's going to happen potentially much later. So in this case, it's actually stored in the class. So if we receive a tapped event, if we don't have a registration for that event, we're not actually going to do anything. Otherwise, we're going to produce a result object. We're going to, because this is an event that can happen multiple times, in this case, we don't want JavaScript to get rid of that callback handler. We want to be able to call that same code every time that this event happens. So we will call set keep callback as bool yes on the result. And this just tells JavaScript to keep it around. And then we're going to call the result. So I'm just going to create a quick project here. So I've created a project. I'm going to add a platform. Some of this stuff might take a minute on this Wi-Fi. Actually, I'll install it from local. I have the same path for my repos on my Windows partition and my iOS or my Mac. So it makes it easy to remember like where everything is. Is anyone following along? Yeah? Okay. No, I really need that piano. Okay, I'll give that a minute and I'll jump back to these slides. So publishing your plugin, as I mentioned, npm is the way that we do it now. And if you want to do that, you'll need a package JSON. And luckily, Plugman can do that for you too. So I get this nice little method here. Let's see if we're done. Yeah. Okay, I'm going to jump back to the plugin. And I'm going to, will it accept? No. Give me a dot. So it's looked inside plugin.xml, and now it's actually stepping me through. I'm going to move that up a bit for you. It's stepping me through. So do I accept that plugin name? Yes. The version? Yep. Description? Nothing. Git repo, author, it's all good. So now I have a package JSON. And I can show you that here. It's very simple, but it's all I need to network again. But essentially, that's all I've needed to publish to npm. So my plugin is live. There's now, what, 1,277 plugins out there. And of course, I can, since I don't want anyone to see it yet, I can unpublish it as well. So unpublishing, I don't know if you're familiar with npm that much, but I can never reuse the version of 001, so I have to bump it if I want to republish it. But of course npm will tell you that. So I'm going to switch back to the testing the plugin. So I've got iOS is added. I'm going to Cordova add, or sorry, plugin add. And I'm actually going to just reference that folder. And I'm going to link. So you can see it installed the plugin for iOS. It also recognized that there's dependencies, so it went and grabbed those as well. So I should be good to go if I want to jump into platforms here. Open up Xcode. And here's my project. You can see in the plugins JavaScript, there's console is there, device is there, and Jesse's plugin ID is there. Jesse's plugin ID doesn't actually do anything, but you can see that it is all hooked up. So on the native side, if you look in plugins down here, you can see the device plugin. And how many people are debugging natively in Xcode for their plugins? So I can show you the mapping of how we get to our actual code. So the device plugin starts up automatically. If we look at the JavaScript side, what we do is we export a new device, and what this does is it actually it will have people explored channels, the Cordova Info Ready channel. So internally, when a PhoneGap app loads, there's a few events that happen. There's device ready that everyone knows about. But before that, there's DOM content loaded, which is, you know, the typical event that people do things as far as their UI goes. But there's also a Cordova ready. This is a way of signaling that the core native side is loaded and ready, even though we haven't fired the device ready event yet. So there's a way that we can actually hook up our code to Cordova ready, and the way that it works is actually Cordova ready happens, then Cordova info ready happens, and then device ready happens. So by subscribing to the Cordova ready, we can actually call this method to get info. The get info method here is actually what does our exec. So it's going to call into the native side before the device ready event has fired. So this means that once the device ready event fires, you can actually get the info. It's already populated. So in this case, we're actually going to fire the info ready channel ourselves. And that's just, device is sort of a plugin that's known to be very useful, and you want that info very early when you're starting. So it's responsible for firing this Cordova info ready, which won't happen otherwise. So we would go straight to device ready. So if I run this here, and did I get my breakpoint in there? Okay, so starting up, and we can see by looking at the simulator, device ready hasn't fired yet. We can see that we've been passed a command, and this command has a callback ID, and then it has its own information, and arguments is an array that's empty. So we're going to do our work to actually get the information that we want to send back, and then we're just going to call plugin result. And now we've received device ready, and all the information is available. So people are very much aware of the core plugins and the fact that what they do particularly is expose native functionality that you couldn't otherwise get inside of a web page. But there's multiple opportunities to actually provide functionality besides runtime. So plugins can actually do stuff at build time or install time even. So plugins at runtime is the model that we're most familiar with. It could be, you know, a UI framework or a library that we want to include in JavaScript. It could be exposing native functions, which lots of them do. But it could also be things like debug logging, logging to file, analytics, other sorts of things that aren't necessarily super visible to the user until there's a problem. And there's also plugins at build time. So at build time, using hooks, you actually have an opportunity to transpile. You can use your ES6 and have it run reliably. Does anyone use CoffeeScript anymore? TypeScript? So yeah, you can use all that. You can transpile. Image inlining, Webpack is pretty cool these days. Browserify is cool, so you can use Node.js libraries right in your web-based application. Or you could be linting or hinting your code just to make sure it meets, like it's going to fail at runtime and you're not going to waste time. And plugins at install time. I sort of showed you one version of that, which is just a collection of other plugins. And also, you could provide tests for a plugin. So I'm going to show you a more complicated iOS demo that demonstrates some UI stuff. So if you want to fork this repo, it actually includes a demo folder, which actually demonstrates some of its features. So I can show you. Okay, I'm going to close this one. I have it open here, but I can show you how to use the demo stuff. So, sorry. Purple Cabbage, of course. PhoneGap plugin sidebar. So currently this is an iOS only one. I did some work on Windows, but Windows is kind of clunky because it's using an iframe to slide out to actually do like a sidebar navigation menu. I haven't gotten to Java and Android yet, but I have been talking to a few people on the Slack, and I think someone will actually do the Android portion for me soon with a little coaching from me. But there are instructions right here. So if you've forked it, and it was PhoneGap, wasn't it? So this is the repo that you'll have if you forked it, and you can just cd into demo and follow these instructions here. So we're actually using --link. I have a demo folder which references. Okay, it's installing status bar, and it's also adding the plugin in the parent folder. So this is a good way if you want to just show a simple demonstration of how your plugin works without the user having to do too much work. So I can nice, okay. Add iOS. not going to add iOS because it takes like 3 minutes, but I'll show you it running in Xcode, and you can wait 3 minutes on your own. Okay, so this is the sidebar demo. I'll just show you what it does first. So in this case, I've also installed the status bar. The status bar actually presents a little bit of a problem with this plugin. Huge. So what I've done is in JavaScript, I've called iTunes an API to return a list of songs, or actually applications, sorry. And that applications, I can't remember the keyword, looks like Cordova or PhoneGap is my keyword that I'm searching for. But I've taken that JavaScript object that I received, I've created an array of all the titles, and then I've called my sidebar native implementation with that array. And did you know that you could have an app titled quote, 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 2015, quote, 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 quote? Surprising what they allow, eh? So this is a native table view in iOS world, and what I've done is I've created it in my plugin. I've attached it to the view, and I've pushed it back one. And so I've added a shadow to the web view itself so that it actually physically looks like it's behind it. And this lets me have like my beautiful scrolling. And I can't customize the way it looks yet, but that's down the road. That's something I want to add. So you can have this, large list of items rendered natively while still using a web view. And so when I select an item, I actually just pass back the index that you selected. So now we actually know what you selected on the JavaScript side. So jumping into how I did that. So here's my basic call to the iTunes store. Explicit, yes, I want all of the apps. Not that you can have explicit apps in the App Store. So then I'm just alerting the response. That was the 200 items that you saw. 200 is the limit that I send. And then I'm just storing this list of items. So I'm just taking all the track names out. They're track names even though they're actually applications. Then my buttons, I have a show panel method and a hide panel method that I've attached. And sidebar show is going to okay, I'm doing something tricky here. So on the click event of the show button, I'll show panel. And I'm calling my JavaScript implementation of the plugin sidebar show. And then I'm giving it a success handler and an error handler. So in error, I'm just alerting. And then the important thing that I'm passing through also is that list of items. So items is an array of strings. So in my plugin implementation here in the JavaScript side, I have a method, two methods that I'm exposing, show and hide. I've got my success handler, my error handler, and then a list of items that I expect. And then I'm just going to call exec with those and pass the items in. Can't remember why I added the true. I think it was just to demonstrate that I could pass a bool as well as a list of items. Jumping to the implementation on the native side. here's my fancy show method. So I first check if I already have a table view showing, because I consider it an error if I receive a second call. And in that case, I'll just create an error. So result with status, CDV command status error, and then I'm passing a message as well to say it is already showing, and then passing that back. But more importantly is the cool native portions where I actually create a table view. First, I'm going to create a frame, so I want to know, because the status bar could be there, or it could not be there, it changes the position of my actual web view, so I sort of need to know that beforehand. So I check that, I make a table view that I'm going to put at the same Y position, so that it's always, whether it's at 0 or if it's pushed down 20 pixels by the status bar, it's still going to appear side by side. Nice magic number in here. That's how far I'm going to slide it out. That should become a parameter at some point. I'm doing the nice Xcode UI table view stuff. Init with frame, I give it a style. I specify myself as the delegate and the data source. And then I'm doing some nice fancy shadow here that I'm going to put over it. There's that magic number again. That's how far I'm going to slide out. And then I animate. So these are all things that I don't think have been explored a ton. So how to actually, implement the native UI around and on top of the web view. So doing an animation and these sorts of things. So you can see that it's not actually that much code here. Now if I switch over to my config XML here, and so if I set status bar overlays web view, that changes whether the status bar is shown behind or in front, and whether it pushes content down. So I'll show you the issue that I had. Okay, there's my nice status bar up top. It's, of course, white with white, which is how you want your status bar to look. But now you can see I've got a problem there, because if I didn't know that the status bar plugin existed, I might never find this out, but I've rendered my shadow over top of the status bar because I didn't know where it was. So in order to fix that, I can change my actual shadow, and if I start my shadow further down, then I'm actually not going to see it over top of the status bar. And this was something that I didn't even think about when I was implementing it. And it was like, oh, I should have a status bar there. And actually, it looks like it's still a little bit there. So it's that thing where you kind of have to tweak with the numbers and make sure that your shadow is going where you expect it to be. Another gotcha along the way is, I don't know if you're, the event that I showed you before where you tap on the top and it'll scroll your web page content to the top, which is like an expected behavior on iOS. That's actually done inside the status bar by creating a scroll view and pushing it to the back. So when I first created this plugin, I was creating my sliding in sidebar view, and I was pushing that to the back. And what I didn't know is that the status bar plugin, which came along a little bit later, was rendering its own view in front, slightly in front of mine. Or actually, it was installing first, it was pushing itself to back, and then I was pushing back behind it. So all of a sudden, my table view wasn't interactive because there was this scroll view that I had no idea was there. So I had to adjust the code so that instead of pushing it all the way to the back, I pull the web view forward. So I make sure that the web view is in front of my sidebar. So I don't really care about the rest of the stack, and the status bar can still do its thing, and I can still do mine, so I can still have interactivity. And that's a little bit of a weakness of the implementing UI on top of the web view, is that you really have to be aware of other things that could exist. The ACE project that Ryan's team has worked on actually gets around this by letting you use XAML to define where stuff appears on screen. If you're familiar with Teleric's projects, they have their own markup that you specify, so you can lay out items and not worry about things overlapping. And that's in native script. So another small thing about what I've implemented here, let me just jump over. So sidebar includes this demo, right? One thing to be aware of too is that you don't want every single person who installs this plugin to have this demo folder accompany every time you install. And the way I got rid of that is I just used npm ignore. So if you fork my repo and you're working with it directly, you're going to have a demo folder in the plugins folder. But if you install via npm, it won't be there. So that minus link that I did is somewhat important, because if I'm working on this project, you can see, I'm just going to remove it. So if I add it again, but I don't use the link, I'll show you what can happen. So I'm adding it again, but not using the link this time. And what this means is I now have inside platforms/iOS, I actually have new versions of those files. And if I were to be working on this plugin and I made some changes that I wanted to keep, and then I came along here and I went awesome, it's still there. I'm not in the right folder, so it's not working. Yeah, because I didn't actually install iOS on this one, so I'm actually in a different location on my hard drive. Anyway, you have to be really careful with prepare, because it can wipe out your changes to native code. there is, unfortunately, no way around the fact that my plugin JS needs to actually be wrapped. So one thing that Cordova is doing when we install a plugin is it's adding this Cordova define require around my code. So this is what I specified as my class path for my plugin. So this, unfortunately, if I want to change my JavaScript, if I'm working on it here, I actually need to go and take, everything inside here and copy it back to my repo. Currently, there's no way around that because we need this when we install, and there's no way for you to specify it beforehand. So, plugin testing. How many people have written tests for plugins? How many people know where to get started with writing a test for plugins? Testing is super important if you want to maintain quality, and the Cordova plugins, the core plugins, all have tests written for them. So originally there was this tool called Medic that was written, and it contained the tests for all the individual plugins itself. We later realized that this wasn't an awesome way to do it, and we started putting the actual tests for each plugin in the plugin repo itself. Of course, the way Medic exists is it will install all of the plugins, the core plugins, and it will install all the plugin tests, and it will run them all, which isn't ideal for anyone who wants to just install their own plugin tests, and run it. So internally, it's using Jasmine. Tests are asynchronous, and the way that we've sort of approached it is, if you look at a particular plugin, you'll see a tests folder, and that test folder actually defines its own plugin. So it's not dependent on anything. It's just tests. It defines a JS module, which is our tests. And if we look at that here, tests are identical across platforms, although you can look at Cordova platform to decide if you want to do a particular test on a particular device. But for the most part, our tests are the same across all the different devices. So there's two important methods that we're doing here. Define auto tests. So these are tests that are just run. I can show you quickly how we actually do this. Let's see if I have a fragment here. Okay, before I get there, I just got to talk about a slightly different thing. That's a convention about how tests are installed for using Medic. But a lot of that idea was reusable, so I rolled it into another tool called Cordova Paramedic. And I thought the Webster's definition of paramedic was fitting for a test that's run quickly outside of the hospital. Medic, in this case, would be the hospital, and paramedic would be out in the field. So Cordova Paramedic will run a test on a particular platform and for a particular list of plugins. So all the things that it's going to do behind the scenes for you is it's going to create a new project in a temp location. It'll add the platforms that you specified. It installs the test framework, which is used to actually run the tests. It installs the plugin that you specified, and it installs the test for that plugin. So it assumes that there is a test folder in your plugin repo, and that it can install that plugin there. It also sets the start page to a test, CDV test page. And this is part of what the Cordova plugin test framework does, is it creates this folder in your project, and it has the test runner. So we want to navigate to the test runner and not the index.html normally. So then the the important part, because we want to be able to use this with continuous integration, is we spin up a small local server and we listen for results to be posted back to us. The way Medic was originally architected was that we would run devices on all the tests, or on all these devices, run tests on all these devices, and they would all be pushed to a server. I was able to leverage some of that and say that server is actually right here on localhost. So that way I can actually get a result on the command line and tell if things were good or failed. So right now it only supports NPM published plugins and platforms. Actually, sorry, not plugins, just platforms. You can't have your own local, branch of iOS and run tests on that directly, but that's something that I'm going to look at adding as well. So that won't work right now. It would need to be Cordova iOS. And actually platform iOS. So I'll show you quickly some tests running. I'm just going to go straight to the device plugin and run the tests on that. So I can just if I could type. So you can see it's specified a temp location that it's going to install this project at. It installs the test framework, which has to come from NPM. It starts the server. It adds the platform. And it should start up the simulator in a second. iOS takes forever to add. Windows is so fast. Oh yeah, I was debugging. And what, I have 2 emulators now? Okay, the tests have started, and just like that, it's actually run all the tests. So I can see a list of the descriptions of the tests, and I can see actually back here on the command line, I've received the JSON object that Medic would have posted to a server, and I'm looking for failures. If I see failures are 0, then I exit with 0. So this allows me to integrate this with Travis CI or AppVeyor for Windows, and you can copy any of the core plugins and see the actual way that it's architected. So yeah, my advice with most things is copy what the core plugins do. And you can npm ignore that test folder as well, if you'd like. It's up to you, because it's typically not huge. Actually, I'll show you the other part of the test. So this is, if you're not familiar with the way tests are written in Jasmine, they're typically, describe is a description of the test that I want to run, should exist. So we expect window.device to be defined. it should have certain properties that we're defining, and basically we're just running through them and making sure that they exist. There's also manual tests that you can add, and I'll just show you. Actually, that's going to take forever again, isn't it? I can reset app, and I can go back, and I can actually run manual tests. So manual tests are a little bit different in that user interaction is usually required. So in this case, I want to dump device, and then I have expectations about what I actually see in that output there, and they're specified here. So this is something where a user would actually run this test and go, yes, I did see what it said I should see. So all the properties are there. So again, the auto test button this is all made for you in the framework. So you really don't have to do much else. There's also logs show up here, which is a bit annoying because there are tons of them. And that thing will pop up every time a new log happens, so even if you're closing it, it reopens. But if you can run it this way and you just see the results, then you're golden, right? So debugging native code in Xcode, I've shown you a little bit of that. We were able to put a breakpoint and see what was actually being passed through. Debugging in Visual Studio for Windows is much the same, and I'll try to show you that here. Get my VM up. How many people are using Visual Studio and doing Windows development? A few of you? And have you written any plugins for Windows? Okay, it's a little bit different in the way it works. On Windows, there isn't the concept of a native side and a JavaScript side. In Windows land, Microsoft has made JavaScript a first-class citizen, so everyone can actually write applications with JavaScript. What this means is in a lot of cases in our plugins where we add a JS module that calls exec, we actually don't need to exec anything, but we want to keep that code around because for the most part it's probably code that you want to run equally on all the platforms. So instead of clobbering it, what we've done is we've created what we call a proxy. So I can show you quickly this device plugin, and if I go back to the plugin XML and look at the Windows section, so we're actually adding what we call a device proxy. So this means that device.js that's defined as a JS module above can still exist, and I can actually proxy what would normally be a native call to another JavaScript class. So here's device proxy. It's got some boilerplate Windows stuff for actually getting the information about the device. But the key point is that it has this get device info method, which is what we've defined as what we're going to call Cordova exec device get device info. So this has to have the exact same signature as what you're calling exec, and you'll receive win, fail, and arguments. In this case, because of the way that we're reusing that JS module, we can actually completely depend on these arguments being valid, because JS modules that are for the shared code are typically doing all the argument checking. They aren't just calling native Cordova exec. They're doing some work ahead of hand. And on Windows, the exec module itself is actually going to guarantee that win and fail are defined for us too. So even if the user hasn't specified them, when we call through to the proxy, they will always exist. So here we are doing some work in Windows SDK, getting some data, and then we're actually going to send a result back. So we're going to call that win method with the object that we expect. We're doing a set timeout here just because it was expected that this native call would be async. So we kind of want to actually maintain that and not have code callback before the caller is potentially ready. I have to add, I'm using git bash for everything. So everything is actually almost the same between Windows and Mac. And actually Ryan is going to be doing a workshop a little later, right after this one in this room, I believe. And he's going to be talking about setting up your environment. And he'll probably tell you about Windows bash and all kinds of crazy stuff like that. But I've always used git bash because slashes are all the same way, regardless of which platform I'm on. And the only little thing here is that I have to add a C in front of my path. So instead of going tests, which would be the root of my Mac hard drive, I have to do C. So I'm going to I was going to show you debugging in Visual Studio. Yeah, everything starts with tests. Maybe it's not faster than iOS. Oh, it is. So I'm going to add the device plugin. And I'm going to jump right in here and open the solution. So, fingers crossed. My VMware partition for Windows is a little behind because I've been working in iOS quite a bit lately, but it looks like we're all good here. Okay, so one small thing that I didn't show you here in this JavaScript file for Windows proxy is at the very end, there's this little bit of magic. We're requiring the exec proxy, and we're adding a key for device. So everything that I've defined here in module export, all the methods, will be mapped to any call to Cordova exec device. So I have to actually supply the same interface that I want called when you call Cordova exec. And this actually allows us to do, this happens before device ready. So there are exec calls that can happen before device ready, and typically the device info is available before device ready, So this is a case where it's really important that we have this available beforehand. So it's actually defined right in the module. So as soon as this module is loaded, this is actually going to be run. So now if we want to, which one am I in? Yeah, Visual Studio doesn't like this resolution very much. So I can set a breakpoint here. Oh, not again. It wasn't liking this for some reason. You ever seen this happen, Ryan? Oh, there it is. Okay. In VMware, Visual Studio was too close to the edge, and it was like it wasn't registering the click there. Yeah, I know. So we can see we're actually calling into our device info proxy, and because JavaScript is a first-class citizen here, we can actually debug not only the proxy code, which technically would be our native side elsewhere, but we can also debug into our callback, and we can actually make sure that everything is happening right. For some reason it didn't break. But I mean, Visual Studio is very good for this, and it even allows, there are ways that you can actually expose native parts, true native parts. So you could write a C# project, and you could reference that, because Windows, with the Windows Universal Projects, they support multiple project source languages. So JavaScript calls can actually bind directly to C# code or to C++ code. So it's actually extremely powerful if you can spend some time in Windows land. Whoa, I'm running out of time. Okay, so I explained the Windows bridge and how that works, the proxy. Everyone have a fairly good understanding of the proxy, the way it's registered, and since there isn't really a native portion, it mimics the native portion. So npm publish, I already published a plugin for you. So then you go and you make millions of dollars with your plugin. I haven't actually figured out how we can do that, but documentation, the fun part. Of course you need them. Typically what we do is we put it right in the repo. We have a README in the root, because that's the way it's usually seen on npm. And typically for you non-first or English as a first language speakers, typically it's English because npm was written in America. Hooks. Okay, I actually want to get to some questions, so I'm not going to do a deep dive into hooks, but this repo, actually first off, the documentation around hooks is very good. I can show you that quickly. So hooks, there's all kinds of events that are happening behind the scenes. When you add a platform, when you remove a platform, when you call Cordova prepare, when you add a plugin, when you remove a plugin, when you're building, when you're compiling. And all of these individual things actually have a way that you can run some code when it happens. So you can define hooks directly in the config XML of a project, but you can also put them in your plugin XML. So in this case, we have this little script here that we want to run every time before a plugin is installed. So we just specify where it is, and this will be run for us. And this is typically Node.js code, and we can do some neat things depending on what we want to do, because we have full access to the project. So Steve Gill, also from the PhoneGap team, made a quick demo here. What he's doing is he's using Browserify, Babelify, and actually, before you prepare, he's actually transpiling ES6 code to ES 2015. So, straight up normal JavaScript. So this allows you to use all your coolness. Let me just, how am I doing on time? 9 minutes. So this is probably one that you're going to want to go explore yourself. He's actually documented quite well. It's actually an application that you can just run. So you Cordova add a platform, and you can run it, and you can see in his scripts here. So he's doing the work there. He's using, because you're in Node land here, you can use all the typical Node modules. He's requiring Browserify. He's going to use Browserify to do some work on the app. And if you look at the actual app that he's got, okay, this is output stuff. So this is the application code that he is going to run his transform on to transpile it. And you can see, he's using some fancy new JavaScript, which will all be turned into good old-fashioned old JavaScript. He's also using a let. And he's got another example here where he's actually importing a Node module, and because Browserify will wrap that for us, you can use, a lot of Node modules work very well in the browser if you use Browserify. So, little homework. Actually, I was always frustrated by the globalization plugin, but mainly because it's async, and if you want to know a localized string now, you don't actually want to have a callback so that you can change the DOM later. But there's actually a new standard out, so this homework, you actually don't need to do it, but just go out and make plugins and send pull requests to the core plugins. And if you want to get a hold of me, I'm on Twitter, and I'll be around all day too, and we can talk some more. So does anyone have any questions? Yep. Potentially, yes. You should be careful with it. You have to make sure that it's something that you really want. And if you do need to do some work beforehand, it's probably a good idea to tell the user to also use the splash screen plugin so that they can show something over their web page while it's loading. Any other questions? Come on, somebody. Anise, how you doing? Anise wrote Plugman, and he came up with the name too. before you came, we actually used it to create a package.json, and yep, and we pushed it to npm, and then unpublished it right away because it was empty. Well, I guess since I have 4 minutes, I'll see if I can get Steve's hook example working. So many tabs. So I guess GitHub isn't down anymore. So follow along here. Okay, I'll just use that one. Let's actually have a look at it. Who's using VS Code? Oh, that's your question, isn't it? Who's using Sublime? I go back and forth. Because of this. Do it. Yeah. When I want to zoom in, I have somewhat challenged eyesight sometimes, and I don't really want the whole thing to be bigger. I just want. Yeah, I could, but still, those icons. Yeah. You are, okay, and that was the other thing. Okay, so I'm just going to, the event that we're hooked into here is, it was prepare, right? So I'm going to just do a console log to show that I'm running something. So I have to npm install because it has some node modules there. It has a package.json, and then I should be able to okay, I can Cordova prepare. Yeah, and there's my console.log. So it's actually run that little node script. So you can do all kinds of things here. The sky's the limit. And the events, there's a ton of events that you can hook into. So this is super powerful, and I don't think it's currently very underutilized because you can do a ton of stuff. Anyway, that's my time. I'm right at 11 o'clock. So last chance for a question. Thank you very much.